Thank you, everyone, for joining us from wherever you are. Could have just like Migota said, could have chosen to be somewhere else, but you decided to come and support us. We thank you so much. I'm Ruth Amolo, and my co-presenter is Nancy Wachira. I am very delighted today to have you with us. I have a bachelor's degree in information technology, and have several achievements that I would like to share with you before I hand over to my co-presenter. First and foremost, I run a website that is called Ruth Academy. It's on the way to be, under construction, and I'm going to share with you what I've been learning through this journey in Python. Secondly, I also have a web hosting company called crazyhost.com. Again, I also do technical writing and general article writing. But when I joined this program, I learned Python, and I'm looking forward to getting a data science in the short term job, so to help me through with what I've been learning. I would want to take this opportunity to thank my instructor, Migot, and Jackie, who is our campaigner, and the rest of you are here with us. Thank you so much and welcome. Nancy, I also want to say thank you for our friends and colleagues at work who helped us to achieve this. My family members, I can see them, my sister, I can see Tyler, I can see many of you have come here to support us. Thank you so much.
Okay, thank you so much, Ruth, for the introduction and for that session. I am so delighted for this day. I've been looking forward for this day. And thank you everyone for joining us today. Just a brief introduction about myself. My name is Nancy Wachira, and I am a graduate of Bachelor's of Science, Business Information Technology. I have over 5 years of experience in working in the IT sector, in the banking sector. And I started this class last year towards the end of November, Introduction to Python and Advanced Python, beginning of this year in February. It has been an amazing journey for me. I have put in a lot of effort to come this far. And to anyone who may be in this session today, it's doable if you are looking forward to starting something. And you just need to be determined and put a lot of effort. First of all, I want to thank God for this opportunity, for bringing us this far. And also thank you to my instructor, Migot, for your support and showing us the way. Thank you to my fellow classmates that we have been together in this journey. I know you are listening and you're joining today. And I also appreciate each and everybody who has joined today, my family members, my friends. I appreciate all of you. Jackie, thank you so much for your support. And Ruth, my co-host today, I appreciate you so much. And generally, everyone who has joined today, feel welcomed as we begin to learn together. And I invite you to feel welcomed and to follow through. If you allow me, I'm beginning by sharing my screen. If you can see my screen, maybe you can show a thumbs up. I'll appreciate that. And today's topic is application of data science to reduce employee attrition. Presenters today are Ruth Amolo and Nancy Wachira. Shared is our LinkedIn and our GitHub account. In case you would like to follow through after this session, you're most welcome to follow us through. So to begin with, I would like to introduce to you some of the terms we will use along our presentation today, and one is employee attrition, and another one is data science. And on a simple terms, employee attrition refers to the loss of staff through a natural process such as retirement, resignation, elimination of a position, personal health, or any other similar reasons. When an employee leaves an organization for whatever reasons, it's regarded as attrition. And on the other hand, data science is a field of study that combines domain expertise, that is programming skills and knowledge of mathematics and statistics, just to draw some insights from data. So, and data are just raw facts and figures that have not been exploited or used. So those are some of the terms that we'll keep using throughout this presentation. So it's good to have a clue of what we will be saying along the way. And our problem statement today is that companies face huge costs resulting from employee turnover, and some costs are tangible, such as training expenses and times it takes from when an employee starts to when they become a productive member of the organization. So considering what's lost when a productive employee quits, just like a new introduction of a new product idea or carrying out a project, or either customer relationship, it takes a lot of time to bring in somebody new, and especially that is by the end they become productive to the organization. So with advances in machine learning and data science, it's possible not only to predict the attrition, but also to understand the key variables that may influence employee turnover and try to mitigate the risk. So in a broad problem area, our focus is to use a machine learning algorithm to predict employee attrition, to understand potential reasons behind the high attrition rate, and to guide the management to formulate policies regarding hiring for future vacancies, and to help the management to offer the right motivation to employees leaving the organization. So those are some of the problems and solutions we will be talking along the way. So just to give a broad introduction, in today's world, attrition is a major problem, and this is across different industries across the world. It is a burning issue from different industries, and with so many people leaving an organization and organizations keep losing talent and knowledge, such as the training involved and the administration involved, it's observed that many attributes leads to staffs leaving an organization, which include mostly but not exhaustively, like the job satisfaction, employers' behavior towards their employees, and most of it is about the salary and incentives. So with the use of machine learning prediction model, we are able to find out some of the behaviors that those employees who may want to leave the organization may show. So our big question today is, why do employers need this analysis? Or why are we even doing it? So we came across a quote that I agree to it, that when you take away the 20 top most employees in an organization, the organization may become a mediocre company. And I tend to believe that is correct, because it's employees who make an organization. They are the ones who determine how an organization how far it will reach. So the better an organization can be able to retain their best employees, that's the best way they grow the organization. So some of the reasons why employers need this analysis is to carefully examine why employees leave. That's a big question. Help employers to put measures to prevent good employees from leaving, and then track attrition figures over time to communicate the overall progress of the business. So the data reveals areas lacking seasoned and experienced workers in companies and whether they should start recruiting. So this also helps a human resource department to know how well the employees are fulfilled in the company role they are carrying out. So attrition helps the human resource department perform better succession planning. The cost of turnover costs a lot of money in the organization and time, and also some customer relations, new product ideas, and some project may lag behind, including loss of talent. So that brings me to the next slide. And here we define what machine learning is. Machine learning is the use of development of computer systems that are able to learn and adapt without following instructions by use of algorithms and models to analyze and draw inferences from patterns of data. So the machine does not have, it works with no particular instruction, but just by use of algorithms and statistics. So why machine learning and why are we using it in this project? It's for it to help us learning models can help process employee data sets and discover different patterns for human resource department. And that will help with the manual examination of data. And we have 3 classifications of machine learning. We have the supervised learning, we have unsupervised learning, and we have reinforcement. So just to give a brief introduction of each one of them. So from my slides, you can see on the screen that they are classified into 3. Under supervised learning, we have the labeled. So supervised learning really describes a class of problems that involves using a model to learn a mapping between examples and the target variable. So under the supervised learning, algorithms are trained using a labeled data set and are taught to come out with specific conclusions based on the historical data that it's input. When we go to unsupervised learning, it's unlabeled. And why is it unlabeled? It describes a class of problems that involves using a model to describe and extract relationships in data. So compared to supervised learning, unsupervised learning operates only with the input data and without expected output. And on the other hand, reinforcement learning, it uses an environment that is not fixed in any training data set. Rather, it has no goal that is required to come up with, and it doesn't even need any feedback that the performance towards the goal may need. So that's a brief classification of different classification of machine learning. So we go to the objective and the scope of this project. The main objective is to predict attrition rate for each employee and discover who is likely to leave the company. This is very important for the management in an organization, and to help the organization to attain its goal effectively, efficiently, and provide competent and motivated employees. And the third reason is to establish and maintain cordial relations between employees and the management. So that brings me to the next slide. And here we talk about the analytical approach. And we start by analyzing or defining what is an analytical approach. Is the use of analysis to break a problem down into the elements necessary to resolve it. So we do the analytical approach by checking missing values in datasets and processing accordingly. We also build algorithms to identify factors that cause employee attrition. And that helps with a check with the algorithm and models which are suitable. And after checking that, we draw conclusions, recommendations based on the analysis. So for part of the data source we used, for this project, we used a training and test data set that is available in Cargo website. That's where we downloaded the data from. So the data contains a record of 1,029 employees. And just to give an overview of other sources to get data from, you can get data from online, from websites, and you can also buy data. You can also use application programming interfaces, and these data are put in file formats in Excel, CSV file, text files, and XML. Those are the formats. And for example, the data that we use from Cargo is in the form of CSV file. So environments and tool for the project, the programming language we use is Python. And we also have libraries such as Pandas, NumPy, Matplotlib, Skykit, and Seaborn. Those are just some of them. And the project structure is from data collection, we go to pre-processing, and then we go to analysis. After analyzing, we go to the train model. And after the train model, we validate. After validating, we predict. After predicting, visualize. And then that's where we visualize. The next step, we visualize the findings. And after the findings, we can be able to draw conclusions. So from data preparation process, and the data collection, that's where we articulate the problem, like identifying the problem. Then we define data required. We gather data from different sources. Just like I said, for us, we got it from the Cargo website. So under data pre-processing, which is the next step, there's the formatting, there's the cleaning, and there's the sampling. And under data transformation, there's scaling, there's decomposition, and there's aggregation. So to begin with the project, under data collection and preparation, we begin by loading data files. And how we load data files, we head to the test and the train, and we named them HR attrition test and HR attrition train. So we import the data using the training set and make the prediction with the test set. And then under data description, the train data, that's where we have columns including attrition, gender, and the role. And then for the test data is whereby we define the unseen data. The next thing we have is the input variables. The input variables, we had 33 of them. And as you can see from my screen, from age, attrition, business travel, all the way to the years with current manager, all these input variables helped us to come up with the conclusion of ways we can know an employee will leave the organization. And there are those that we needed particularly, and those that we didn't need, we had to remove them in the next stages of the project. So we have the feature set data set. Our data set is called the HR. We have 35 features, 1,029 observations, 3 features and flaws, 23 integers, and 9 objects. As you can see from my screen, the train data set head has different columns from the age, attrition, business travel, all the way to education. Just that a sample of how it looks. And at this point, we have not done anything to this data. We have just like highlighted the train data head to see what it contains. So that brings me to the end, and I will now take this opportunity to invite my co-presenter, Ruth, to continue. And thank you so much for holding through as we continue through this project. I appreciate each one of you. And if you have any questions, keep them coming through the chats. We shall answer them at the end of the presentation. Thank you and welcome, Ruth.
Thank you so much, my co-presenter, Nancy. I hope all of you are comfortable. And thank you once again for your continued support. So I'm going to pick it up from there. Yeah, so my co-presenter talked about the features. She talked about the columns that you have within the data set, talking about the age and the rest. I'm not going to list all of them. So before we analyze our data, we need to pick the columns that we want to use. Not all the columns that you see there are relevant. For example, if you want to produce your model, maybe the employee number may not be necessary. And then again, you may not just dismiss a column just like that. You need to find the correlation between those variables. Again, there are two things that we can use to be able to fish out what we don't need. We call that correlation and the p-value. P-value, that is talking about the probability, whether you reject or accept the hypothesis that you're trying to come up with. Then we have the correlation. What is the closeness between those variables that you have? For example, she talked about the 35 of them. How is the age relating to the job role and something like that? So you'll have to drop some, you'll have to pick some. So as we move along to the next, sorry. We need to visualize. How do we visualize and see the relationship between variables? How are they linked to the employee attrition? So it's important for us to see that and visualize. Python, the language that we used is very simple and very interesting. It has some codes that are available and methods that are available to help us to get the relationship and the correlation between this variable. So as you can see, we have a code that is in the box form. We produce what is called a heat map. And this heat map, we are going to use what is called a CBON. CBON is just a set of codes which is already ready for us to use. So as I move on, this is the sample of the heat map. It's gonna show us the relationship between the variables. You can see as it tends to 1, that is the correlation is stronger. Then we have it tends to negative, we have -6. They're weak, and then also we have the colors. Where the colors are stronger, then we have the correlation is stronger. So as we move along, we also produced some graphs to check how the correlation between the features that we had. The first one there, we had the attrition. Of course, we have a number of employees. The first one at the corner there on my left-hand side, that is the attrition graph. Of course, we have numerous employees, and you'll find that not many of them will be leaving. So that attrition is showing that the number is small. But we also need to know the reasons why they're leaving. Just like my colleague had talked about a number of employees a few number of employees may leave, but you find that this may be your top 20 employees and they are the talented employees. So if they leave your organization, you might be in trouble. Then the next one, we categorize them according to the business travel. Remember our data, there's a column called business travel. So we have some colleagues at work that travel frequently, some of them don't travel frequently. So they were in text form, but they were converted into numerical format. So we had category traveling, category 0, category 1, category 2, and category 3. So according to our graph, we realized that people in category 2, they were traveling a lot, but then again, we discovered that a number of them were also leaving. So probably they were able to make connections when they were traveling. So I'm just assuming that's an assumption. So that one, when you analyze, you'll be able to discover that. Then again, we looked at the department. The department 0, they're fewer in number. Then the department 1, they're quite a number in that department. But then again, we realized that there are also a number of them are also leaving the company. Then department 2, again, it follows, it comes in second according to the number of people who are leaving the company. Then education field, again, education field number 1, more of them were employed, followed closely by number 3. Again, field number 1, it seems that they were in demand, so they were leaving, or I'm assuming they were leaving the company, probably because that field is competitive. So we had several of them. We had gender also. We had gender 0 and gender 1. So gender 1, we realized that there are quite a number. According to our data set, more of the male were employed, and then we realized that also more of them were leaving the company as compared to their female counterpart. Again, we have the job roles, those who are job role 6 and job role 7 are the highest number in the company. And we realized that job 6, 2, 6, and 7, also a number of them were leaving the company. When we also looked at the marital status, we also realized that we had marital status, we categorized them into 3. So 0, 1, 2, and 3. So marital status 1, quite a number of them were employed, but again, marital status 2, a number of them were also exiting the company. So from our projections, we realized that we had to prepare this raw data. That was just raw data, so we had to prepare it in a way that it can be used by a machine learning model. We had 6 distinct steps that we used. First, she talked about our data set, which we extracted from Cargo. It was in Excel and in a format called CSV. CSV is just comma-separated text. And then we imported libraries. These libraries are just text codes, which are already ready-made codes, so we can be able to use them to build our machine learning model. Then we import our data set. The data set is basically the data that we are bringing in from Excel. Then number 4, some of this data is missing, as you will see later on. So we'll have to deal with it. Then number 5, because we talked about some columns that had labels in them, labels are just text. So our machine learning models may not work with the new text. So we had to change them, that is convert them to numerals. So we call that encoding. So we call them categorical data. Then we had to encode. Encode simply means to convert them to something that the machine can be able to understand, that is the numeric data. Then our data, because we are training the data, we are working with the 2 different sets. One is called the training set, and then the test set. So the training set is what we are training, then the test is what we are using to test what we have trained. So our next step, the first step was just initial analysis, which we call initial exploratory data analysis. So our next step is the exploratory data analysis. As you have observed, that was raw data, but this raw data needs to be processed and it needs to be organized in a particular order so that the machine model can be able to work with it. We also need to prepare it and clean it. So we also, in the process, we'll be able to investigate and also get some interesting relations among the variables that we had. How is this age related to job role? How is age related to gender? And also we'll be able to detect any kind of anomaly that may be in that data. Then we will also get to better understand our data, and also we'll be able to identify any kind of error that was captured in that data. So Python is very interesting because it has very, very, very nice methods which you can use to analyze the data. One of them is called describe method. It is able to give us a summary of what our data is in terms of the maximum, that is the max. You can see on my screen, if you look at the first row, that is the first row, we have the maximum age. It is revealing to us that Probably this is the retirement age, because that is the highest number of age we have there. Then we also have the least, their mean, which is 18. So probably the person, the least person who is engaged there is 18 years old. But again, we discover from our data set is that we are supposed to be having 1029, that is 1,009 observations. But again, according to this data set, we are only having what? 819 and 93. Oh, that means some data is missing. So for the machine model to give us something which is correctly predicted, we have to deal with the missing data. So if you look at that, we can see distance from home, again, some data is missing. And among others, we have daily rate for the employees, that data is missing. But you don't worry, because Python will help us to deal with that once we've discovered the anomalies and also the missing data. So we go ahead, once you've noticed that your data is not up to date, you go ahead and perform the cleaning process. The cleaning process, you deal with the incomplete data. For example, if we had data that was fielding a column that missing children. Let's say you have adults that had missing children, a column that you are supposed to miss to insert children for maybe a spouse or something like that. Probably that person was single, so that could be a 0, yeah. Or we needed to input the actual data. So missing data, you can either have missing data because the person never entered the actual data, or it was supposed to be empty. At times, the data may also be duplicated, so we need to get rid of the duplicated data. So cleaning is very important. It takes almost 70% of data science work. So you need to get your data ready for the machine learning model to work. So in our data set, we realized that we had 3 columns that probably we had to get rid of. One of them was the employee count, and another one was over 18. We realized that that column was just populated with yes, 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 yes. So everybody was over 18 years. And then standard hours was populated with 80, 80, 80. So probably that was the number of hours that each person was supposed to work for. So that would not make any difference regarding the machine learning model. Sorry. So as I told you earlier, Python is very interesting because it has methods and tools that enables us to extract some very key insights into the data. So we were able to identify the missing data. As you can see what I've cycled there. Data that is missing will be indicated with the 3 letters AN. So AN means the data is missing. So we can be able to know actually what is missing and what is not missing. According to the test data set, we had 2. Remember, we have the training set and the test. So our test had age, 55 of them were missing. That was about 12.5. Then distance from home, that was 54, that is 12.2%. Then daily rate, that was 14, that is 3.2%. Then business travel, that was 5, that was 1.1%. Marital stressors, 3, that is 0.7%. Then again, you realize when you're analyzing data, if about 70% of data is missing, that means you probably need to get rid of that column because you'll not be able to predict well. So if we look at what we have here, the percentages are quite low, so we can be able to go ahead, proceed, and correct whatever we need to correct. Sorry. So in order to deal with, when you're cleaning data, we used several options. One of them is called imputing. Imputing is basically filling the data. You can fill it with the mod, that is the statistics now, the median, that is the middle value. So you look at your data set and you can use different methods to fill in the data. So in our case, we decided to use the median value. So for the age, we were using the median value to fill the missing data. So we don't just fill the missing data, because you realize that if a person was given age and they had other columns that were not empty, so it means we cannot give them 0, 0, 0. So we had to fill them with the median values. So if you look at my screen, that is a code in Python that we were using to fill the age with the median value. And then after which we display to check if it has been filled. Another method that we used to clean the data is called label encoding. Label encoding is very, very important. Why? Because I told you earlier that machine models, some of them don't use numerical data, but you realize that some of our columns, like marital status, gender, they were all in labels or text. So we had to convert them into numerical data so that the machine model can be able to work with them. As you can see on the screen, we have what is called sklearn, that is helping us to encode the data. Then from there, after cleaning the data, we had to choose the models, and we chose a few models here. One of them is statistics, gradient descent, decision tree, random forest, logistic regression, k-near neighbors, Gaussian naive Bayes, and perceptron. These were some of the models that we used in our attrition prediction. They were using what is called supervised learning. And my colleague had just explained what supervised learning is. Attrition is a very big issue in our industry. And when employees just leave, it's not just about employee attrition. This thing you can also apply to customer attrition. If you have these websites where people buy, like Jumia, you find that customers, why are customers leaving? So you'll be able to predict. So attrition is not basically for employees, but also e-commerce sites. You can use that to perform attrition. So if you can be able to accurately predict which customer or employee is going to leave, and the organization will be able to make arrangements. How much time will they need to prepare and things like that. So what these models do is to use the old data that is already present with the organization. That data you'll find with the HR department of the company. So it will help them to hire, to substitute the person who is about to leave. Also for the website, the e-commerce site, they can be able to launch campaigns. Yeah. So if they launch campaigns, they'll be able to get more clients to fill in the gap of the clients that are leaving. So when we move on, after choosing the models, we train them, you test, update your models, and then we predict. So on the screen, I just chose a couple of them. I did not pick all of them. So we had logistic regression. We used logistic regression to make the predictions. And then this model was able to give us 82.99%. Then we build this model with the selected features. As I indicated earlier, one of them is also called a random forest classifier. So as we move along, you'll be able to see some of the predictions that we had. Then after that, we did what is called model evaluation. Once you've done your predictions, you need to evaluate what you're actually predicting. So one of the methods that we used is called confusion matrix. Of course, there are so many other methods. So confusion matrix is a tool within Python that was able to help us evaluate our classifiers. So to check how they are performing. So it will provide us with a clear picture of the performance of these classifiers that we had. So we'll be able to generate these metrics. We call them precision, recall, and F1 score. So the confusion matrix is just like a matrix, yeah. It's laid in n by n matrix. Yeah? So we have there the 4 boxes. The first column we have the TP. Yeah, TP stands for true positive. Yeah, and then F stands for false positive. Then FN stands for false negative, and TN stands for true negative. I'll explain as we go along. So when we are predicting, evaluating the models, when we say true positive, what we mean is that when we are doing the prediction, what is it that the actual, we are going to get the actual and what the predicted values as positive. Then when we say false positive, it means that the actual value that we are predicting is negative, but we predicted it as positive. Then when we say true negative, it means that both the actual and the predicted values are negative. Then when we talk about false negative, it means that the actual value is positive, but we predicted it as negative. So we then generate an HR classification report. So in this report, we had what is called precision. I'll just explain and illustrate what this precision, recall, F score, and support for each class. So what we mean by this, I'm going to give you an illustration because most people maybe may not be able to understand what this precision is all about. I lost my bank card some time back. That is Coop Bank, Cooperative Bank of Kenya's card. So I had to make a call to the bank in order for them to verify, to check for me if any of my accounts had issues. So what, to ensure that my existing account is safe and secure. So in order to ensure that there's no future risk, the bank manager had to ask me to recall any instance that had my card exposed. Did I use it anywhere else, or did I use it in any other public system, or did I give it to any other person? So in this instance, the system should be able to use it and to precisely predict, yeah, if the card was used, yeah. So that recalling, it might be 30% or it might be 90%. So that is basically how this system is working. So it works with the precision is almost like the opposite of recall. So it might be able to recall, that is remember, and also to predict in a precise manner. Then the other metrics which is used is called F1 score. So the measure of how precise the classifier is. So this is just like the mean of recall and the precision. Yeah. So the greater the F1 score, the better is the performance of our model. So it ranges between 0 and 1. So as you can see from my screen, I was not able to show you the whole code. So that one, if you want to get it, you'll be able to see it from our GitHub accounts. You'll be able to see how the code works. So for the random forest, the precision was 0.98. As you can see, that knife base was 0.79, recall was 0.85, and F1 score was 0.9. Then the accuracy at 0. Sorry for that. Yeah, the accuracy was 0.8470. So you can be able to see my screen. You'll be able to see that. And we can see the support vector machine was rated, their precision was 1. That was very high. So basically, we were able to put them in form of we were able to graph them in form of figures. So we can see the logistic regression. The true positive was 285. Yeah. Near neighbors, the true positive was actually 258. So you can see the figures are quite varied. And for a support vector machine, the true positive was 286, while random forest, the true positive was 282. So if you check our GitHub account, you'll be able to see the code properly. Then I was also able to design the bar graph just to display how this confusion matrix was able to show you how each model performed. We had the random forest, the green bar was the precision, and the blue bar is the recall, and the F1 score is the yellow one, and the green one is the accuracy. So that is the code for the confusion matrix on screen. So that is what we are able to use in order to get all that. Then we are able to generate the report again. Then validating the model, we used also cross-validation. So because of time and space, we were not able to show you the graphical representations. And finally, want to wind up by saying this is just the bigger picture of everything. You can see the power of machine learning, that you are able to determine factors that make an employee to leave using our model rather than using human judgment and manual rules. You can extrapolate what you're doing here to idea in order to achieve in other domains, just like I've talked about the e-commerce and many other areas. So the procedure we used, you can use it in any other machine learning model. We gathered the data, we prepared the data, we chose the model, we trained it, we evaluated, and tuned our hyperparameters, and also did the predictions. So at this juncture, I want to say thank you so much. And I want to appreciate all of you for creating time to be here and to listen to our presentation. All the questions, you can forward them through the message system. And thank you so much for being here for us and being here with us. Thank you once again. I hand over to Jackie.
Hey guys, the presentation was absolutely amazing. You guys have done awesome. I'm going to ask you one question. Somebody's wondering, how long does it take for you to be able to learn all this information? Give me 1 second, let me scroll up. And it's to you and to Nancy. How long will it take for non-ICT trained personnel to learn this program? Would you guys like to answer that question?
Yes, Jackie.
Yes.
Okay, well, all I will say, it also determines the pace of someone's learning.
Right.
There's people who will do it more faster than others.
Okay.
But the key thing is how well you understand.
How long did it take you to understand?
I will say 6 months, but I'm still learning. I've not yet stopped. Okay. I'm gonna continue.
So what would you say for someone who started from scratch? Like yesterday, they got up and they had no idea, they weren't in this field at all. And today they want to start now. What would you say? And they're eager, they have a fast pace, but they're eager, but they are a blank slate?
Let them give themselves at least from 3 to 6 months if they are fast learners, and put more effort to it and determination. It's achievable.
Oh. Motion Arts, what would you say? How would you answer that question?
Yeah, thank you so much. Yeah. You need to dedicate yourself to this. It doesn't matter whether you have previous experience in programming or not. In fact, programming may or may not be an advantage to you, because there are people I know who didn't know how to write even a single code, and they're doing great. They challenge us in class. Yeah.
So it's possible to come from a blank slate to actually come up and have something.
Yes, very, very much.
Okay. And you say maybe 4 to 6 months is a possibility?
Very possible.
Okay. So let me see if we have any further questions. Guys say excellent presentation. So we see that. We see how long would it take. Logistic regression estimates the effects of independent variables, the result of variable probability. Yeah, we talked about that. Everyone says sounds good. Pretty much everyone is absolutely. Could you tell me more about the, one second. Could you tell me more about the naive Bayes in the confusion matrix? Would somebody want to talk about that between Motion Arts and Nancy? The naive Bayes in the confusion matrix.
I'll go ahead and take over that one. So if you
okay.
mind, I know that's from Janabi.
Okay.
So naive Bayes basically refers to a classification matrix. So they came up with this name. They named it after somebody who was very, very involved in the research. Okay. So this is among the simplest Bayesian network models. So when we use it as one among so many other models to be able to help us predict and determine how best or how accurate the model or how accurate the data set we have is going to be able to determine close to what we are looking for. I don't know if that's answering you, but it really simplifies the task. So these are libraries which are available, but they are more on the statistics side of things. So we do a lot of math, we put in a function and then we name it. Let's say we name it Janabi, and then we use it, and then we credit to Janabi for coming up with that model. Is that good? Answer for you, Janabi?
It answers my question. I don't know, does Janabi want to say something? If I ask the question, I'd know the answer. Janabi, are you good?
Let me simplify one more. So it's a classifier, right? It's a model to help us classify. So it's a simple classification model we use in probability and statistics. Okay, it helps us build fast machine learning models that can make quick predictions. Okay, that means it predicts on the basis of the probability of an object. So your prediction normally will really depend very much on the data. If you have a clean data set, then your prediction will be clean. If you have a dirty data set, your prediction will not be that precise. So it goes back to the garbage in, garbage out concept in computing. And also to piggyback to what Ruth said, this is employee attrition. Now, if you flip it over, it can also be very helpful on the customer attrition. If, like, for example, in a website or in a supermarket environment, if you only collect the right data set. So if you have the right data, and then you have the right data points, then you can be able to plug that in and then be able to tell, for example, if somebody come to the website, they click around and then they add things to the shopping cart. And then suddenly there's a lot of shopping carts like just lying around with the items picked but not checked out. So you probably want to check and make sure that you get the right data set and then use that for your prediction to see what can we do different to make sure that we don't have a lot of abandoned shopping carts on a website or even in a supermarket, in a real brick and mortar supermarket. So this is just a tip of the iceberg, but you can take it across the board and apply it to anything. It could be in a church. You want to know why people don't give you, for example, donations. You can use it in any environment where this relationship involving like a customer or a congregation, for example. Okay, I think Janabi is satisfied with that. Okay.
Yeah, Janabi is good. Janabi is good. And somebody
Thank
says,
you very much. That was clear. That was very clear. I'm not as fast as the ladies, but I'm going for it. I'm trying.
Yes.
Thank you, Janabi.
All right. Any other question?
My guy states that he's gonna send it to his HR so that they need to use it at his company. And congratulations, girls. You look smart. That is from Lucy. Great presentation, excellent presentation. So everyone is pretty much really excited. And my guest is gonna use it. We talked about naive base. And everyone says this is amazing. Or somebody asks, hi, Jackie, would you advise companies who would adopt this model? Well, I don't know that I would be the one advising, but Migo, would you like regards to that?
When you say a model, we talk of different models, naive base or this concept of employee attrition as applied to data science? Can you drill deeper?
I think this concept in general.
Okay, so I would again, like Ruth and Nancy said, I would really recommend it for any company which wants to know the trend of things, especially in the era of COVID. We know there's a lot of companies, some of them, they lost a lot of employees, either by moving to other places or just some employee did not make it through COVID, they died. So you probably want to plug something like this to help you determine what can you do best to attract people on board. It could be money, it could be the distance from work, it could be flexibility of work. For example, we here in the US, in our industry, and I know some of you will attest to this, there's some companies which they strictly want you to be in the office. And there's some companies which they really don't care so long as you do your job. And between those two companies, let's say A and B, you as an employee, you could be having both qualifications to allow you to work in both companies, but you might just be looking at to see, okay, they're paying more, but they want me to be in the office, or they're paying whatever I'm asking for, but I don't need to be in the office, so I can work in my pajamas in the house. So that's also part of employee attrition. And that decision-making will probably be taken over by somebody who is in the HR to see what's best they can do to help. Okay, maybe we can just say, you don't have to work every day in the office. You can come maybe twice a week, maybe twice a week this week, and then next week come 3 times a week. Or you can decide, you say, we are going to go ahead and improve the benefits. You say, we give you additional benefits in terms of less insurance coverage and stuff like that. So this can be employed, this concept can be employed in a variety of areas. Employee attrition in itself is just one area. Okay, again, going back to what Ruth said, we can use it in e-commerce circumstances. You can use it in any other company. You just have to have the right data set to make it happen. Okay. I hope that answers.
Thank you.
Okay. Okay.
Yes, it answers my question coming as a layman. So I'm thinking, from anyone's question, I feel that guys are answered correctly.
Yes.
Can you guys see me?
Yeah, we can see you.
You can see and hear me?
Yeah, we can hear you.
Perfect.
Mhm.
Okay. Yes, me got you answer the question.
Okay, cool. All right, so I see somebody. Okay, this must be maybe Ruth's sister. Lisa Amolo says, hijack, kindly share the recording of the presentation. So we are going to go ahead and clean the video, and then once we clean it, then we put it on YouTube. So you'll be able to get on YouTube. No worries about that. And then if you want, you can also join some of our WhatsApp groups. Then you can also be able to look it up. Okay.
I want you guys to listen to what we have this comment here from Jonah Owiti. Wow, lovely. This is informative. I am 70 next birthday, some 37 years ago. Specifically IT security areas, going to find out more about this program. Really enjoyed the data presentation, cleansing and predictive parts. This is amazing. He's 70.
Yeah.
Or she's 70. It's
that's when life starts, right?
Mask set.
Yes. Congratulations, Jonah, and we hope you got more from this, but we can still use your wisdom, by the way. So this is not like the end of everything. We will always spread out, and hopefully we share ideas, because I mean, you cannot be successful all by yourself. You know, like somebody said, I believe Isaac Newton. There
you go. And Jonah is a man.
Yeah.
He says it's a he.
Yeah. All right. So this guy stood on the shoulders of giants in order for him to be able to discover so many things for us, which are helping us in physics and science nowadays. So, yeah.
Right.
Okay.
All right.
Okay. We still welcome more questions if you have any.
And Migor, then I'm going to hand over to you.
Okay. Thank you. Okay.
I don't see any further questions in the chat or from the people, so I'm going to hand over to you, Migor.
All right. Thank you very much, Jackie. And looks like Ruth and Nancy, you guys killed it. If you don't see no question, that means you guys did a good job. And I cannot emphasize how proud I am to let you guys know that now you officially graduated as what I call data scientists. I mean, you can do it. And thank you all very much for doing it. And, for those people who came, we really appreciate you. We really cannot say thank you enough for spending your time with us. We know very well that you could be doing something else at this particular time, but you chose to be with us. And thank you very much. And this video, we'll clean it and then we make it available for everybody to be able to view it. Okay?
Amen.
Thank you.
Thank you, Migor. Take care, everybody.
Thank you.
Bye.
Thank you, guys.
Thank you, Migor. Thank you, Ruth. Thank you, everyone. Thank you, Jackie.
Thank you.
Thank you. Take care.
Thank you, everyone.
Take care. Bye.
Bye. Thank you.
Bye-bye.
Thank you.